Hi, my name is Sunny Solanki and you're tuned to Coders Column. In today's video, we will build a background removal app using Python. For building our app, we will be using Python libraries Streamlit and PyTorch. Streamlit is one of the most preferred libraries nowadays to create web apps and dashboard using Python. Because it requires a few lines of code to create an app using Streamlit and the app looks nice as well. Now for detecting background, we'll be using a pre-trained image segmentation model named FC-ResNet101 available from PyTorch. The model will segment an image into various parts, one of which will be the background. After detecting the background, we will make the background transparent using our code. Okay, so before we start with the coding part, let me show you how our final app will look like once we are done with the coding, so you get an idea. So as you can see on my screen, I have a sample image open of how our final app will look like. So app will have a title and below that we will have a simple widget to upload files. So we'll let user upload PNG, JPG and JPEG images using this widget. So once user upload an image, the app will run the pre-trained PyTorch model behind the scene to detect and remove the background. And once the background is removed, it will display an original image and the image without background. Alright, so that's the app that we are going to create. So without further delay, let's get started with the coding part. Alright, so as you can see on my screen, I have an IDE open. And as you can see, I will be using a Visual Studio Code Editor for our tutorial. And I have already opened a file name background_removal.py. So we will be keeping the code of our app into this file. So as you can see, I have some amount of code already present in this file. So I have included code to load the model and make predictions. So let me explain you the code first. And then we will go ahead with creation of layout of our web app. So at the beginning, I have a few imports. I have imported Streamlit. Then I have imported Torch and Torch Vision. So Torch Vision is another module available from PyTorch, which is specifically designed to work with computer vision tasks. From Torch Vision, I have imported this function name FC-ResNet101. So this function will help us load our model. And then I have also imported weights of that model. In the next line, I have imported draw segmentation mask function. So this function will help us highlight various segments of our image. So we will use it to highlight background. And then I have a import function named toPIL_image. So this function takes as input PyTorch tensor and converts it to PIL image. Next to that, we have a NumPy array. And then I have import from pillow named image. Right. So after all the imports, the first thing I have done is I have loaded the weights. So I have kept this FC-ResNet101_weight, and on that I have called this constant name Coco with VOC labels v1. So what this will do, it will load the weights of the model which is trained on a Coco dataset. So Coco dataset is a very famous dataset for computer vision tasks related to object detection and image segmentation. And from this weights, then I have again loaded a function named transform, as you can see, and this will return me another function which I have saved to preprocess func variable. And this function will be used to preprocess our image. So it takes as input raw tensor image, and then it will prepare it for our model. So basically it normalizes our image by subtracting mean and standard deviation by dividing by standard deviation. So that's a function which we'll need to call before giving an image to our model. And then I have stored the categories. So list of categories are available from meta and categories key of that meta dictionary. So yeah, as you can see, there are various categories named background, aeroplane, bicycle, bird, boat, and so on. So there are 21 categories which are available. Alright, and then next I have created a dictionary. So this dictionary, what it does is it maps categories to list of integer values. So all categories will be mapped to values in the range 0 to length of categories. So that's a dictionary, and we'll be using this dictionary. So next, what I have done over here is I have created a function named load model, and over here I am calling this function FC-ResNet101, and there is a parameter named weights where I am giving the weights which we loaded earlier. So this weights is a enum Python object, and it has information. So it has a URL from where this function will download the weights of our model. Yeah, and after loading the model, I have set it in eval mode. So that's what you need to do in case of a PyTorch. So after you set it in eval mode, you can go ahead and make predictions, and it won't calculate gradients. So I have called a load model function over here. Yeah, and the next function I have defined over here is a prediction function. So this function can be used to make prediction. So it will take as input a processed image, the image which has gone through this function, pre-process function. And over here, then we are calling this model, our loaded model, giving it an image. And over here, as you can see, I have called unsqueeze method to introduce batch dimension, because majority all the PyTorch model works on a batch of images. Yeah, so output of this function is a dictionary, and it has two keys named out and aux. So I will be taking the out key value, and then I am calling a squeeze on it. So it will remove that this extra batch dimension, and then I am calling a softmax on it. So it will convert all the values of the output in the range 0 to 1. So output is of the shape 21 by width by height. So if the image shape is 500 width and 400 height, then output will be 21 by 500 by 400. Now the 21 represents different categories. So 21 categories. So output is basically a mask. So mask has values in the range 0 to 1, and there are masks for all the categories. So whenever the model has detected presence of some object in our image, so the values of that pixels will be near 1, and all the other values will be near 0. Yeah, so over here we are converting our mask from value 0, 1 to Boolean mask. So I'm setting a threshold over here of 0.8. So after we have set this threshold of 0.8, this condition of normalized underscore brace greater than 0.8 will convert our normalized brace to a mask. So again, the output will be same as 21 by W by H, but for all the pixels where the value is greater than 0.8, we'll have true as a value, and all other pixels will have false as a value. So basically we will have a mask in our image. So mask has the same shape as that of our image, and the mask is present for all the 21 categories. And for each category, if the object has been detected at particular pixels, so the odd that pixels will have value true, and all the remaining pixels which are not part of object will have value false. So that's what is the output of this function, which is mask. And then we have one another function named add transparent alpha channel. So what this function does is that it takes a below images input, and then it adds a alpha channel to our image, and then it checks for the white background, and then set that background to transparent. So let me explain the code. So first of all, we are calling convert method over here, which is getting called on PIL image, and we are giving it mode as RGBA. So this part of the code will convert RGB image to RGBA. So if the image has a shape W by H by 3, it will be converted to W by H by 4. The fourth channel will be alpha channel for transparency. Next, I am creating a mask over here. So I am calling array of : 3. So first 3 channel it will take for all the pixels, and if that all the 3 pixels has value 255, 255, 255, which is for white color, then the mask will have a value true, otherwise it will have value false. And then over here again I am calling all function on mask. So this will convert our mask from the format W by H by 4 3, w by h by 3 to w by h. So now we have a final mask of the pixels where background is present. So we convert it from boolean to integer. So whenever the value is true, we will set it to 0. So 0 will be full transparent background. And if the value is not 0 or true, so if it is false, then the value will be 255. So that's the alpha. And then I have called our array, and for the -1 channel, so for the 4th channel, we are setting this alpha. So now we have our array ready where we have a transparent background. So over here we call image.fromArray function, and this will convert our array to pillow image, and then we are returning this pillow image and we will display it in our dashboard. Alright, so let's get started with the coding the layout of our app. So first of all, I will add a simple title to our app, and I will say background, and I can use title function available from Streamlit to add title. I will say title background removal app, and we can add various emojis by putting the name of the emojis inside of columns. So I am adding 2 emojis which I usually use for my tutorials, which is tea and coffee. So now we have added title. Next, let's add a simple caption. So there is a caption function which let us add a small light gray color text. So over here I will say PyTorch image segmentation model FC-ResNet101 to remove background. So now we have title ready. So next we will create a upload widget. So for that there is a function name file uploader, and over here first thing I will add is a label. I will say upload image here. Then I will set a type. So this is the type of files that you allow. So I will allow PNG, JPG and JPEG, and the output of this I will store it in a variable name upload. So once you upload any image through this widget, the image will be present in this variable upload as a byte string. So if upload is set, I will put an if condition. If upload is set, then we go ahead and make the prediction on our image, or we go ahead and remove the background of the image. So first of all, if image is present, then I will convert this byte string to this pillow image, and I will store it to image. So once image is loaded, then we need to convert this image to PyTorch tensor, because PyTorch models and various functions requires input as a tensor. So we will say torch.tensor, and in order to give this image to tensor, in order to convert it to tensor, we first need to convert it into numpy array. So I will call it np.array and image. So this will convert it to tensor, and I will say image tensor. Now the function, or all the functions or model, as I said, of PyTorch requires channels details to be present at 0. So once you do np.array, the actual image shape will be w by h by 3, but all the input function of PyTorch requires channel to be present at beginning. So it requires it in the format t by w by h. So in order to do that, on this numpy array I will call a function named transpose, and I will give it to 0 1. So the actual third channel or third axis values will be pushed to the first axis. So now we have image tensor ready. What we will do, we will pre-process our image. So I will copy this pre-process function, and we will give it our image tensor, and the output will be processed image. So now we have processed image ready. Now we can give it to make prediction function to make prediction. So I will say process image, and output of this will be masks. Output will be 21 by W by H. So mask for each 21 categories. So now we have a mask ready. Next, what we need to do is that we will use this function to highlight the background. Draw segmentation mask. So let me copy it. So input to this function first is image tensor. So this original image, and then the second is mask. So I will give mask, and I will give index the mask, and I need index for background. For that I have created this last to index dictionary. So I will use last to index. Inside of that I will copy this underscore underscore background underscore underscore. So this will return me index of background, which is 0 in our case. So mask of 0 will be the mask of the background. Next we need to set two other argument alpha. So alpha is opacity of this detected object. So for background I am setting it to 1.0, and colors I will set it to white. Now you can set any other color as well. If you set, let's say for example, green color, then you will need to modify this function add transparent alpha channel, and over here you need to check for green color. Okay, so yeah, it's the choice is up to you. In my case I have set it white color as a background. So output of this function I will store it to variable name image with pg removed, and this alpha is opacity of background. So this accepts value in the range 0 to 1, and you can use it for different purpose. If you are detecting persons in an image, then you can set it to 0.5, so you will be able to see person behind that particular mask. Okay, so now that we have removed the background, so basically we have actually detected the background. Now what I will do next is that I will convert this one to PIL image. I will say image with background remove. And now we will give this PIL image to this function alpha channel, which will remove the background. So image with PG removed. Okay, so now we have final image ready where the background is removed. Now what we can do is that we can go ahead and divide the horizontal space of our dashboard or our app into two columns, and in the first column we will display the original image, and in the second column we will display this image without background. So let's do that. In order to divide space into two columns, I will use a function named columns, and I give it integer value 2, so it divides it into two equal columns. There is a parameter named gap which I will set to medium, and it can accept small and large values as well. It's a gap between the two columns. So output is call1 and call2, two column objects. Now we can use this column object as a context manager. So I will set it over here call1, and first of all I will add a header. So there is a function named subheader which let us add any kind of header. So over here I will say original image, and same I will do for call2 as well. And over here I will add title image without background. Okay, so now we have two columns ready. In order to display image, there is a function named image, and this function accepts a numpy array bytes IO string as input, or even a pillow image, and it will display it. So first of all I will display original image, so I will give it image over here. So image is our pillow image, and below that I will again call image for this second column. For that I will use this image with bg removed, and image with bg removed is also a pillow image. As you can see over here, I have called image.from array. Alright, so we are done with coding of our app. Now let's go ahead and test it. So as you can see below, I have already terminal open, and I am currently in this directory YouTube tutorials and image segmentation, and I have kept my file over here. So in order to run Streamlit app, there is a command name Streamlit run and then name of the file. So I will say background remove dot. So once I execute this command, it will start a new server and it will open a new tab in the browser where our app will be displayed. Okay, so the server has started, and as you can see, new tab is opened in the browser as well. And as you can see on the top right corner, the app is currently running, so it's executing the code. Okay, so app has loaded successfully. Now let's go ahead and test our app. So I have few files already, so let me go there, and let's first of all try this dog image. So I will click on open, and yeah, and the app is running the model behind the scene. And yeah, as you can see, the app seems to have removed the background. It seems to have done a nice job. So I can right click on this and save an image as well. Dog2 I will say. And yeah, let me show you the image. And yeah, as you can see, the background is removed. It did a good job in this case because it was only one object present. So let's try few more images. So let's try this girl image and see how our model is doing. Yeah, so as you can see, in this case, it's doing a good job, but there are some pixels from the backgrounds are not removed. So now in order to do this, what you can do is that in our code, as you can see in this function make prediction, we set threshold at 0.8. So whenever for any pixel, the model was confidence more than 80%, then only we included that pixel in our image. So if a model is confident that this particular pixel is background and it's confident more than 80%, then only it will be included. So what you can do in order to remove those kind of edge scenarios, you can set probability low. So let me set probability to 0.5 and see whether it's improving our model or not. So let me rerun this one. And yeah, now as you can see, now it has done a good job. The model has improved a lot. As you can see, it was detecting some of the background over here as a part of this girl object. So that's gone. Let's try one more image, which is over here, which is of family. And before doing that, I will again set this threshold to 0.8 because in case of that as well, it will detect background. So let me load image again of the family. So now the model is running, and as you can see, in case of this family image as well, it's detecting some of the background as a part of this people objects. So what we can do, we can again set threshold to 0.5 and check whether it's improving or not. So I will click on rerun. And yeah, now as you can see, the results has improved a lot. So yeah, that's it for this video, and we are done with the creation of our app. Now before we end this video, I want to bring few things to your attention. So one of the first thing is that this kind of model, image segmentation model, takes up a lot of memory, RAM, and I am running it on CPU. So as you can see, it's using 8 GB of RAM on my end. So all these models of image segmentations are big and they require a lot of space to run. So if you have a GPU, then I would recommend that you run this prediction task on GPU. So you will have to make few changes to our code. You will have to put this model to GPU, and all the tensors which we are creating, so this pre-processed tensor, this also you will have to put to GPU before giving to model. So all the processing happens on GPU and your CPU is free and not using any RAM. So in that case, this app will work quite fast. Other than that, so we used the FC model in our case, but PyTorch has many different models, DeepLab V3, LRASPP, and there are few models like FasterRCNN and so on. So I would recommend that you try these models as well, as they can give better result than the model that we used for our case, which is FCN. And yeah, you can go ahead and check our tutorial. So I have a tutorial on my website on image segmentation, which you can explore to learn about. And other than that, what you can do is that in our case, I used PyTorch, and Torch is in submodule of PyTorch for our image segmentation task. Now, other than that, there is another Python library named GluonCV, which also provides image segmentation facilities. And GluonCV is a computer vision library of MXNet. So MXNet is another deep learning framework just like PyTorch. So if you want to use GluonCV for image segmentation task and to detect the background and remove it, then you can use it as well. Alright, so that's it for today's video. And as you can see, we were able to create our app in just 65 lines of code. If you have any doubts or any questions, then please feel free to let me know in the comment section. And yeah, if you liked our video and you feel that you learned something new today, then give it a thumbs up and keep subscribed to our channel, because we will be uploading more videos on topics like Python, machine learning, AI, and so on. And yeah, see you next time.